So, question 4, g of x equals 4 over x minus 6 plus 5. X is a member of the set of real numbers. Sketch the graph y is equal to g of x. Label any asymptotes and any points of intersection with the coordinate axis. So, standard sketch and label the important points kind of question. So, we need to build this up and think how we do that. So, we start with an x because they're the input values. And the first thing that happens to it is we get to x minus 6. So the graph of y equals x minus 6, we should know is going to look through like that. And there's the minus 6. But actually, we've changed the x here. So if we think about this as a transformation, it's a translation. And we moved it down because we know what x minus 6 looks like. But actually what's happening is we're changing the x value, so the graph is moving across 6 because this is at 6, 0. And it so happens when the gradient is 1 that it goes through minus 6 as well. Okay, the next step then, in terms of giving this shape, is to take the reciprocal. So we get 1 over x minus 6. So this is the bit that basically gives us the shape of the graph. So we're going to take the reciprocal. And if you take the reciprocal of this, we know the asymptote has to go through the point 6 because that is where the denominator is going to be 0. So this is our asymptote at x equals 6, and we've got our reciprocal shape graph. Now we multiply by 4. So we get 4 over x minus 6. So we know that that's a stretch. Scale factor 4. And it's, if you like, outside the bit that's giving the shape, yeah? This multiplying by 4 is outside the reciprocal, the bit that's giving it shape, so we're seeing it 4 times 1 over x minus 6. So it's a stretch scale factor 4 with the x-axis invariant. X-axis invariant. So our sketch is now going to look something like this. It's still got that same shape, and the only thing that's really happened in terms of the sketch is the coordinates of this point have changed. So this is x minus 6. Now we're going to add on the 5, so 4 over x minus 6 plus the 5. That is outside the function, yeah, outside the shape. We're adding 5 onto it, so it's going to be a translation of 0 across and then 5 up. So we should now be able to draw our final answer. We've got an x-axis and a y-axis, so there's x, there's y. We've got an asymptote at x equals 6. And we've got another asymptote at y equals 5, because the x-axis was moved up by 5. So our graph now fits in, our graph now fits in here. Oops, done that wrong. It's going to cross the y-axis. And again, you should draw your lines with a ruler so you can show the values tending towards the asymptotes. This isn't particularly good down the bottom here. So, hi. It's all right.
You this whiteboard. I want the whiteboard off.
So we've just got to get this line in the right place. There we go. Oh, I just need to get rid of that little tail down the bottom there. Ah, it doesn't let me do that. That's annoying. Let's try again. I'll put the tail on again. I'm not going to rub it off again and see it vanish. Okay, so that shouldn't be there. Yeah, this little bit down here shouldn't be here. Hopefully that's clear. That bit there shouldn't be there. Sorry. Okay, so we now need to find these 2 points, the point of intersection. We've got our asymptotes labelled. That was x equals 6. So at x equals 0, that's where it crosses the y-axis. We've got g of 0. G of 0 is equal to 4 lots of 0 minus 6 plus the 5. So that gives us negative 2/3 plus 5, which is equal to 4 1/3, which you could write as 13/3, whichever you prefer. 4 1/3 or 13/3. Similarly, we need to find the x value when the output is 0. So when 0 is equal to 4 over x minus 6 plus 5. Yeah, so this is the root. Usual approach, multiply by the denominator, so we get 0 is equal to 4 plus 5 lots of x minus 6. Expand the bracket, plus 5x minus 30. Add the 30, subtract the 4 is 26 equals 5x. So x equals 26 over 5. So that's 26 over 5, or 5 1/5.